So let's go through this topic of geometric sequence, and there's the equations really that I've prepared that answers really and covers really various dimensions that examiners really like asking this question in their exams. So the fundamentals or the background information you need to know about geometric sequence is that the general formula for it is a is equals to r to the power of n minus 1 really, and where a is your first term and where there's r, it's your constant ratio. And really we can calculate our constant ratio, which is r, by saying term number 2 divided by term number 1 and term number 3 divided by term number 2. And n, it's the term number. For example, let's say calculate 6th term or calculate 3rd term. This is really what they're referring to, n. So to calculate the 6th term, you just substitute 6. To calculate 3rd term, you just substitute 3 where there's n. To calculate the 23rd or the 1000th term, you substitute n for that value. So Tn is really the term value. Remember we said n is the term number, so this gives you the value. So if you substitute 6 where there's n there, it will give you what the value is of the 6th term. So really don't confuse the two, but I'll give you an exercise. Really we'll be doing an exercise that will iron out that ambiguity. So let's go into the first really question. We're given the geometric sequence, that is 3, 6 and 12, and it continues, and we're asked to calculate the general term. General term means we need to find what a is and what r is. Our a, it's given a is equals to 3. We need to calculate what our r is, or our common ratio. We just say it will be 6 divided by 3. 6 divided by 3 to give us 2, and we're going to say 12 divided by 6, which will give us 2. Means that our common ratio is 2. Therefore, general term is given by Tn is equals to our a value is 3, and our constant ratio is 2 to the power of n minus 1. Therefore, we've answered the first part of the question by calculating what our general term is. So we can move on to the next question, calculating what the 23rd term will be. 23rd term. So how do we get or calculate our 23rd term? That's number 2, our 23rd. But then the third term is nothing more than taking our general term, which is Tn is equals to 3, 2 to the power of n minus 1, and saying where there's n, we're going to substitute 23. So we're going to say 23. 3 times 2 to the power of 23 minus 1. And we're just going on to our calculator, type in 3 to the power of 23 minus 1. And then our answer will be 12582912. It's 12582912, and that will be our 23rd term. And we would have answered our question and gotten all our marks. So we can move on to the next question that pulls up our knowledge on geometric sequences, which is B. And this question says the geometric sequence has a first term of 1 and a constant ratio of 2. Determine the term which will be equals to 32,768. So let's all write down what we know. We know that our first term a will be equals to 1, and we also know our constant ratio r is equals to 2. So therefore our general term of our geometric sequence standard form is that. So the sequence, we know that a is 1, r is 2, and n minus 1. So therefore we can just write it as Tn is equals to 2 to the power of n minus 1. But you're told to determine the term, and term, whenever you see term, always remember in which term will be equals to. Really, 32,768. So it means where there's Tn, you just substitute 32,768, and we'll have 2 to the power of n minus 1. So in this instance, our main focal area will be calculating what our n value is. So we need to find what n is, and we can find what n is by using something called logs. So whenever you're given an equation, exponential equation of y is equals to a to the power of n, right? Where you're looking for n is unknown, so we'll apply logs. That is log of a to the y is equals to our exponent. So we're going to use the same theory, same logic, saying log. In this instance, our a value is 2, say 2, and our y value really is 32,768 is equals to, and our exponent is not only n, it's n minus 1. Let's move our workings there. So we have log of 2, 32,768 equals to n minus 1. Remember, we're solving for n, so we just punch this into the calculator to see what we get as an answer. And we get the log of 2 to 32,768 is 15, which is equals to n minus 1. We take the 1 to the other side of the equation. We get that n is equals to 16. So in that regards, we would have calculated it's the 16th term really, which is equals to 32,768. If you want to confirm that, you can take n of 16 and substitute it back into the original equation by saying t16 is equals to 2 to the power of 16 minus 1, and you will see that it will give you really the same answer, 32,768, which confirms that the answer of 16 is correct. And this is what I love about sequences. You can always verify or check your answer to make sure that you're banking all the marks in the exam. The next question, we're given that the first 2 terms of the geometric sequence, of which, so determine the first 3 terms. So that's the question, the first 3 terms, and we're told that for which the third term is equals to 8. So it means that third term t3 is equals to 8, and also we are told that the 15th term t15 is equals to 32,768. So now we need to determine the first 3 terms of the sequence. How do we do that? Remember, we're dealing with a geometric sequence, so the back of our heads, we need to know that the general term is Tn is equals to A R power of n minus 1. So we have to write these equations in that form. So how do we go about it? I'm going to say T3 is equals to A R to the power of 3 minus 1, but we know T3 is equals to 8, so we say 8 is equals to A times R to the power of 3 minus 1 is 2. And we have our first equation, which is the same thing for T15. T15 is to A times R to the power of 15 minus 1. T15 is equals to 32,768. A is equals to R to the power of 14. So you can see that we have really 2 equations. So the easiest way here is to, instead of using substitution, we can just use really elimination by dividing these 2. So let me just write these equations down. Here is 32,768 equals to A R to the power of 14, and 8 equals to A R over 2. What we'll be doing, really, we can just also quickly label, just label this equation 1 and equation 2. Means this will be equation 1 and this will be equation 2. So what we were doing, the procedure here, will be saying equation 1 divided by equation 2. Then we're going to say 32,768 divided by 2. to give us divided by 8, I meant to say. Divided by 8, we get 4096. And if we divide a by a, we get 1. And if we divide r to the power of 14 divided by r to the power of 2 and laws of exponents, we know that r to the 14 divided by r to the 2 is nothing more than r to the 14 minus 2, which is r to the 12. So we have r to the 12. So we can take this working here and continue solving for r. So we have 4096 equals to r to the 12. So the same as saying r to the 12 is equals to 4096. And how do we get rid of that 12? We can just say really the 12th root of 406. Or if you're not comfortable with that, you can simply just say 4096 to the power of 1 over 12, and it will give you answer. So say 4096 to the power of 1 over 12 in your calculator, and you should get your r value to be 2. So now that we've calculated our r, we can substitute our r in either equation 1 or 2. Any equation, either equation 1 or equation 2, but you can see that equation 2 looks much more simpler. So let's substitute our r into equation 2 to make our work very, very easy. We're going to go and take equation 1, which is 8 times r squared. We're going to say 8 is equals to a, where there's r to substitute 2 squared, and therefore our a value will be equals to 8 divided by 2 squared, which is 4. It's nothing more than 2. We found out our a is and our r is, but the question is asking you to determine the first 3 terms. And how do we determine our first 3 terms? We determine our first 3 terms by saying t1, t2, and t3. So therefore we can say our general term is a value is 2, r value is 2, and minus 1. So we need to calculate what t1 is, which is our first term, but we really don't need to calculate it because we know that it's 2, but we just go ahead and calculate it. T1 means with this n, we're going to substitute 1, means t1 is 2 times 2 to the power of 0, should be 2 times 1, which is the same as 2. Then we go and calculate our t2, it will be t2 to the power of 2 minus 1, which will be equals to 2 times 2 to the power of 2 minus 1 is 1, 2 times 2 is 4. Calculate our t3, which should be 2 to the power of 3 minus 1, which will be equals to 2 to the power of 3 minus 1 is 2, which will be 2 times 4, because 2 squared is 4, and 2 times 4 is 8. So therefore our first 3 terms of the sequence will be 2, 4, 8, and it will continue until infinity. And that will be our first 3 terms answering this question.